Here are some important points on electricity, class 10th NCERT chapter. So let's start. A continuous and a closed path of an electric current is called electric circuit. Electric current, which is denoted by I, is expressed by the amount of charge flowing through a particular area in unit time. Such that we can say that I equal to charge upon time, which is charge is denoted by Q, and the SI unit of charge is coulomb. Now we can say 1 coulomb is equal to 6 into 10 की power 8 electrons, and 1 electron is equal to 1.6 into 10 की power minus 19 electron. No, we can say electron is not, that's my mistake. Okay. Electron possesses negative charge, which we can study in like further 11th class or 12th class about the whole charge chapter. SI unit of current is ampere, which is named after a French scientist named André Marie Ampere. 1 ampere is denoted as denoted or constituted by 1 coulomb of charge per second, such that I equal to 1 coulomb per second. We can say 1 coulomb equal 1 coulomb by 1 second. Now, small quantities of current are expressed in milliampere, such that 1 milliampere is equal to 10 की power minus 19 minus 3 ampere, or 1 micro in microampere we can denote as 1 microampere is equal to 10 की power minus 6 ampere. Okay. Now there is a device like there is a device, or like we can say in physics, there is a instrument that is called ammeter, which measures electric current in a circuit. This is the closed circuit, in which to make a closed circuit we have to attach wires, batteries, switches, ammeter and bulb. Okay, so current flows from positive direction to negative direction. So when we join all the like plus minus ends of all the bulb, emitters, cells, and the bulb will glow. Now let's see an example. Question is given: a current of 0.5 ampere is drawn by a filament or bulb for 10 minutes. Find out the electric charge. So we have given current is equal to 0.5 ampere and time is equal to 10 minutes, which we have to convert into second, that is 600 second. Now we know charge equals we know that current is equal to charge upon time. From there, t is multiplied by I, so charge is equal to I into t. So q equal charge is equal to current into time. So we have to just put the value 0.5 ampere into 600 second is equal to charge equal to 300. So our next topic is potential difference, or we can say electrical potential difference. It is the difference between 2 points in an electric circuit carrying some current as the work done to move a unit charge, or we can say electrons, from one point to another. Potential difference is denoted as V, that is equal to work done upon charge. W is equal to work done and Q is equal to charge. Now the SI unit of potential difference is volt. 1 volt is equal to 1 joule divided by 1 coulomb. So from that, the coulomb is like go to the numerator, and the power becomes -1. So 1 volt equal to 1 joule coulomb to the power -1. Potential difference is measured by an instrument called voltmeter. Voltmeter is the device that measures the potential difference when current flows from a circuit. So we have to attach the voltmeter like ammeter, like which we show in the previous diagram. Remove the ammeter and attach the voltmeter, so it calculates the potential difference. Now next point is Ohm's law. Ohm's law is given by a German physicist named George Simon Ohm. It states that the electric current flowing through a metallic wire is directly proportional to the potential difference V, such that temperature remains the same. Or we in the equations we say that V directly proportional to I. to remove the to do the proportional sign, we have to use some constant. So if we say that V is equal to Ri, the proportional sign is removed and it comes to an R is the constant that is that we have used to remove the proportion, and now V is equal to V by I is equal to R. We can say, so R is the constant for metallic wire at given temperature. It is called resistance. R is called resistance. So from that our formula becomes V equal to IR, and this is the Ohm's law. V equal to IR. Okay, now resistance is the property of conductor that resists the flow of charge through it. We can say that resistance it cannot it like opposes the electrons or flow of charge from the in a wire, or like in from to in a conductor. The SI unit of R is ohm, denoted by this sign ohms. So from the Ohm's law we can say that R equal to V by I. Okay, here is the VI graph. You see that we can calculate this is the line of R. So we can say that if we like put the values here, 0. Like we can say 0.4 is equal to V and 0.1 is equal to I. So from there we can say that R is equal to 4. This is the point. So from here we can say R is equal to 4. It is same. 4. The value of these are, if we have 4, 4, 4. R is same for all the values. For all the values of V and I. Now, if the potential difference across the two ends of a conductor is 1 volt and current is 1 ampere, then R is 1 ohms, denoted by this 1 ohm equal to 1 volt by 1 ampere. Also, from the Ohm's law, we can say that I equal to V by R. Now, there are some factors on which the resistance of a conductor depends, such that on its length, R directly proportional to L. It means that when R increases, when the length of the conductor, or we can say wire, increases, then the resistance also increases. Area of cross section such that R directly proportional to 1 by area A. We can say that when resistance increases, area of cross section decreases. When the area of cross section is low, then R becomes high, or we can say and it also depends on the nature of the materials. There are some metals, I can show you the table. This you can consider the NCERT chapter 12 of science. There we can show the table, or I have included it in the video also. Now from those values like R directly proportional to N and R inversely proportional to 1 by A, R directly proportional to 1 by A. So R directly proportional to L, we can say that from this and this we can say that R directly proportional to L by A. So now to remove the proportionality, we have to use some constant, and we have used rho. Rho is the electrical resistivity. The SI unit is ohms meter. Ohm meter, not ohms, ohm meter. And according, like if we prefer some metals like insulators, conductors, or insulators are those which cannot pass the current through it. Alloys are those which passes like little amount of current, small amount of current, and conductors are which passes current without any opposition or any resistance. So they are the good, or we can say good materials for the flow of the electricity. And now we can say that in the resistivity of insulators are higher than the alloys, and alloys have the higher resistivity than the conductors. Let's take an examples. So here are some examples. Okay, so we have given, these are the NCERT examples that I use. Okay, So we have given V equal to 220 volts and R1 is equal to 1200 volts, that is of filament, or we can say bulb, and R2 is the resistance of heater coil, that is 100 ohm. Then we have to find the current I and I2 for both the for filament, how much current will it flow in the circuit, and for heater coil how much current. So according to the Ohm's law, V equal to IR. For filament, for first we will calculate for filament. So according to the V equal to IR, I1 equal to V by R1. That is 220 volt by 1200 volt. No, 220 volt by 1200 ampere. No, 1200 rho. No, 1200 ohm. Okay, so I1 equal to 0.18 ampere, and for heater coil it's 220 by 100 is equal to 2.2 ampere. Now another example is given like V equal to 60 volt and I is equal to 4 ampere. Now V is increased to 120 volt, then find current at 120 volt. So first we have given the potential difference equal to 60 volt, then now after increasing it to 120 volt we have to find the current. So according to Ohm's law, V equal to IR, R is equal to V by I. That is, so this is before the increment of the potential difference. This is the resistance before the increment, and the resistance will remain same if we increase like potential difference, or if we increase potential difference, then the resistance is also increasing. So the question is not for any increasing not for like showing the if. So let's come to the question. So after R equal to V by I, R equal to V by I, we get 15 ohm, and now V equal to 120 volt after increment. So I equal to V by R. So we have find the value of R, 15 ohms. So if the voltage is 120 volt, then the current will be the 8 ampere. Let's go to another example. Given resistance of metal wire of length 1 meter is 26 ohm at 20 degrees Celsius. If the diameter of wire is 0.3 millimeter, then find the resistivity. So according to the factors affecting resistance, R equal to rho L by, that the formula we have derived using the factors. So rho equal to R A by L. A will go to the A will multiplied by R, and L will divided by both these. So now in the question we have given R equal to 26 ohm and L equal to 1 meter. Diameter is equal to 0.3 millimeter. So we have to convert it to meter. So this 3 into 10 to the power minus 4 will come. Now area of cross section equal to pi d square by 4. This is the common, we can say, commonly used area. So we for in this in the electricity chapter we commonly use area of cross section in the resistivity part, this pi d square by 4. So now rho equal to 26 into pi d square by 4 into 1, that is the length. So our resistivity will come is equal to 1.84 into 10 to the power minus 8 ohm meter. Now come to the next point. We use resistors in gadgets in two combinations method, series and parallel. So in series, the current flowing through all the resistor is same, but potential difference is different, such that I is same. Let's say there are three resistors, 1, 2 and 3. This is R1, R2 and R3. So the current flowing through them is plus minus. The current is same. As you can see, the current it will go to first R1, then to R2 and R3. But the potential difference we measure using voltmeter, but it is different for all the resistors. This is V1, V2 and V3. So now the total potential difference of this circuit, okay, we can complete the circuit, this and this. So the total potential difference of this circuit is V1 plus V2 plus V3. and the resistance in series is equal to R1 plus R2 plus R3. So to prove the resistance in series, we know that V equal to IR according to the Ohm's law, and V equal to IR for V1, V1 equal to IR1, for V2 equal to IR2, for V3 equal to IR3. The total V in series is equal to the sum of V across each resistor. So the total potential diff according to this, so we have used this equation, V equal to IR1 plus IR2 plus IR3. V1 is equal to I, you can just, okay, so V equal to I, we have can take the common I, and then R1 R2 R3. So we also know V equal to IR, so we have put IR equal to I. So after this equation, I and I will be cut, or we can say divided by, so it will be cut. So R equal to R1 plus R2 plus R3, and this R is the series resistance. So this one is the proof of this. Okay, in parallel, the potential difference through all resistors is same, but the current flowing is different. Hmm, let's see let's see the circuit diagram. So this is the our first resistor 1. This is our second resistor, and this is our third resistor. This is R1, R2, and R3. Then the potential difference is same. Circuit I have not run, but you can assume. So potential difference V is across all the resistors is same, and the current, the current I1, I2, the current is different because first the current will grow into R2, and then R2, and then R3, R1, R2, R3. So the current is different. If one resistor will not work, this is the benefit of parallel combination, that if one resistance cannot resistor does not work, then other two will continuously working without any harmness, or we can say short circuit, or you can imagine. Okay, now it is observed that total current in is the sum of all the current flowing in the circuit. Now the current in parallel is equal to the I1 plus I2 plus I3, sum of all the currents. Okay, to prove now, in parallel, the resistance of this circuit is the reciprocal, in the form like 1 by R1, 1 by R2, 1 by R3 is equal to 1 by RP. So we know, so to prove that, we know that V equal to IR, I equal to V by R. So the total current is I1, I2, I3. So we have to put the values here. V equal to I equal to V by R1 plus V by R2 plus V by R3. And now IP is also, we can say, V by RP according to the formula. Okay, so we have to, the V and V will be cut, and 1 by RP equal to 1 by R1 plus 1 by R2 1 plus is plus 1 by R3, and this is the form of parallel combination of resistors. So our next point is heating effect of electric current. The electric circuit is purely resistive. If the electric circuit is purely resistive, this source energy continuously get released in form of heat, or dissipated in form of heat. This effect is used in electric heater or electric coils. Like now, according to this heating effect, the power is equal to V Q by T, and we know that Q by T is equal to I. So power is equal to VI. Now the heat is the form of energy, or we can say energy, that is equal to the power, in that is equal to the power, that is equal to the power generated into time used. So according to P equal to VI. So here we can form an equation, H equal to VIT. Then using Ohm's law on this equation, we get H equal to I square RT, and this is the Joule's law of heating. So our next point is electric power, the rate at which electric energy is consumed in an electric circuit. We says that V equal power P equal to VI, P equal to I square R equal to V equal to IR. So we have just put it here, V equal to IR, then I square R from this, and after that we after that I square equal to V equal to IR, I equal to V by R, and I square is equal to V square by my R square. So from here we get V square by R. The SI unit is watt. SI unit is watt. 1 watt equal to 1 volt into 1 ampere is equal to 1 VA. Now generally we calculate power in kilowatt. What is this small what is this small SI unit? But generally in real world we use kilowatt. So 1 kilowatt is equal to 1000 watt, and electrical energy is the product of power and time, such that heat is the form of electrical energy. So now he E, or like we can say H, this is same, not different. So is equal to P into time, that is watt hour, WH. So uh, here are some conversions that will use in the that using the questions of NCERT. You can solve from there. So 1 kilowatt is equal to 1000 watt into 3600 seconds, and 3600 seconds is equal to 1 hour. That is converted. Okay, so 1 kilowatt is equal to 3.6 into 10 to the power 6 watt per second. So 1 kilowatt is equal to 3.6 into 10 to the power 6 joule. That is, joule is the SI unit of energy.